Okay, this is question 24. I'm just going to get the calculator back here. Let's just get that the right size. There we are. And expand that a little. Oh, right, okay. Now, question 24, it says Beth ran a 200-meter race. So Beth's running 200 meters. Here is a graph of the first 8 seconds of her race. Okay, so this represents 8 seconds, and you can see that from this point here on the graph. This is obviously 8 seconds here. She completed the race at a constant speed of 9 meters per second. Okay, so after this point, she's running 9 meters per second. Okay, so the first thing we need to do is to figure out what distance has she covered in this part of the race. So what distance has she covered here? And you should remember that the distance under a speed time graph is given by the area. And let me tell you and remind you why. Remember that speed is distance over time. So if I rearrange this to get distance is speed times time. I multiply both sides by time. So it's speed times time. Okay, so speed, which is this axis, vertical axis, times time, horizontal axis. So if I multiply this times this, I get an area, don't I? And that's why it's the area of the graph. So let's work out distance travelled in the first 8 seconds. So let's write first 8 seconds here. And so the distance that they've gone is the speed that they were doing, which is 9, times the time that took them 8. So this is 72. Sorry, it's the area. So it's half of that, isn't it? Because it's a triangle. Half the base times the height. So half of the line. So 72 over 2, which is 36 meters. So she's covered 36 meters in this first 8 seconds. Now that means that the remaining distance to complete the race is 200 minus 36 meters, which of course is 164 meters left to go. Right, so we need to now work out how long it's going to take Beth to do that at 9 meters per second. So the time to cover 164 meters, we're going to rearrange this equation again. Speed equals distance over time to get time equals. So we're going to get time equals distance over speed. Now the distance travelled is 164 meters and the speed that they're doing is 9. So what's 164 divided by 9? That's 18.2 recurring. So time equals 18.2 seconds. So that means the total time for Beth is the 8 seconds that she did on this graph here, plus the 18.2 seconds here, which of course adds up to 26.2 seconds. So did Beth finish before Amy? Well, Amy took 27 seconds, and Beth only took 26.2, so therefore Beth did finish before Amy. Notice that we conclude, answer the question. Did Beth finish before Amy? The answer is yes, with the appropriate working shown. Question 25. The dimensions of a regular floor are, to the nearest 0.1 meters, like this. The force of 345 newtons is applied to the floor, and the force is to the nearest 5 newtons. Work out the upper bound for the pressure Okay, so in other words, we want the largest possible pressure. So if we want the largest pressure, call that pressure max, then we want to get the force as large as possible, so that's the maximum force, divided by the smallest possible area. So that's actually the area minimum. Okay, so we need to find the bounds of these things. So we want the minimum area. Now, how do we find the minimum area? Well, first of all, we know that the area goes between the minimum area and the smallest possible length for this is 2.5. The nearest 0.1, so this is 2.55, that's the nearest 0.1, isn't it? If we rounded this up, and less than 2.65. This 6.4 goes between 6.35 up to 6.45. Okay, so my area, I need the minimum of these multiplied together. Remember, the area of a rectangle is length times breadth. So this is 2.55 times 6.35, going all the way up to 2.65 times 6.45. So my minimum area is this, goes into there. Okay, so my pressure max is force is definitely 345, we're told that. Area minimum is this 2.55 times 6.35. So let's work that out. So we've got 345 divided by brackets 2.55 times 6.35 close brackets equals, and this is 21.3 to 4 significant figures they want, so 21.31, isn't it? 4 sig figs. Now, the pressure, we should write the units as well. Oh, they've given us the units here. That's fortunate. Now, if we didn't know the units, what we can do, we know that this is force is newtons, and area is meters squared. So that's where we get newtons divided by meters squared, newton per meter squared here. Just in case you were asked to do that in the summer, 21.31. The diagram shows a square lengths are measured in centimeters. So we've got a square. Look at the length of one side of the square. Okay, now if this is a square, we know that these lengths are equal. So we're told, therefore, this 3x plus 4, isn't it? Yes. That's a divide sign now, I think. Is it a plus? Oh, it must be a plus, surely. Can't quite see. That's gone a bit funny now. Just open this again. Second. To close this, I think. Seems to have crashed. Just bear with me a second. Start it up again. Okay, let's just look at that. I might have to get the original one. Just so look, question 26. The photocopy doesn't quite work here. That's a plus. Okay. So we know that the length times breadth. They're equal, sorry, I think about it. They are equal. The length and the breadth are equal. So we can simply solve this now. Multiply the brackets. Subtract 3x from both sides. Subtract 6 from both sides. Divide both sides by 4. Work out the length of one side of the square. That is asking us to calculate this. If x is 2/3, therefore one side is, which one we use? 7x plus 6. 7 times x, there's my x, plus 6. This is 14 over 3 plus 6 over 1. Common denominator 3. 3 to 3 goes 1, multiply that by 1. 1 into 3 goes 3, multiply that by 3. So we get 32 over 3. And the units are centimetres.